All right, so for number two, um, we have a block. Now, I would say this, this question, it adds a bit more difficulty because the force, well, usually the force that we see, they are usually along the slope. But as you can see right here, it is not along the slope. It's kind of pushing into the slope, okay? So that's something you might want to consider. Okay. Now, let me ask you something, like just general common sense, if you think about this. If the force is being applied this way, okay, pushing into the slope, is it easier to move the block or harder to move the block? Why? Uh-huh. Yeah, so you're pushing into the slope, so it's going to be harder. So when you say harder, what force increases? And what makes it, quote unquote, harder to move forward? Friction, okay? So we'll see how friction will increase as a result. Now, as you can skim through the problem right here, no numbers whatsoever, pure conceptual, okay? So let's go ahead and draw the free body diagram. How many forces should there be? Which one? Which four? Normal force, gravity. You have applied force. Yeah, I think FG is fine. Yeah. And then friction, it's this way. Okay, because the block should be going up, right? Starting up, so friction will be going down. Yes? Okay. All right, so that's part A. All right, part B. Okay, part B. It says derive an expression for the normal force exerted by the surface of the block. Right now. So before we do this, how about we do the following? Can we go ahead and draw the block again? But with this one, we are going to break it down into components. We're going to break down the force of gravity into the two components. So that we can see things better for our forces, and also we're going to break the applied force into two components too. So the applied force would be Fx and Fy. We have Fgy, and we have Fgx, and we also have kinetic friction, and then we have a normal force. Okay. So there are a total of 6 arrows right there after you break those components down. Now, like I said before, some people think that physics is hard, and the way to make things easier is that you possess the initiative to do the things that you could, such as label all the forces, break down all the vectors into components. So if we want to calculate the normal force, or write an expression, so where should we start with that expression? What should be the first line of writing? F net, yes. So I would say the F net in the y direction is equal to 0. So therefore, the normal force minus the Fg of y minus Fy will equal to 0. Okay? So now the challenge is, well, n is simply equal to Fgy plus Fy. Now, if you look at the request of the question, it says express all algebraic answers in terms of m, F1, theta. That's right, my bad. No, right here. It sets. Wait, hold on. My bad. I copied the wrong question. It's the acceleration. Develop an expression for the acceleration. Somehow it jumped ahead. But that diagram would still be helpful for us. All right, develop an expression in terms of m, theta, f, mu, g for the block's acceleration up the plane. So actually we have to erase all of these for the moment. Okay. All right. How? Good. Why is that square root?
Oh, because I didn't realize that y would be 0 at first. So just like
Oh, okay. All right. Now, so this is something that you will see, and now we when we say acceleration up the plane, so that means the net force is not 0. So that means F net is equal to ma. Okay, and the net force is in the x direction, so we say Fx minus the kinetic friction minus the Fg in the x direction is equal to ma. And now we've got to break things down. So what is Fx? F, and then? Yeah, but for the Fx, Fx is not just F. You have to break it down. We have to break down the F so that it has two different components. So so how do we break this friction down, this applied force down into two separate components? Okay, so that will be your Fx right here, that will be your Fy right here, and this is your little theta. Okay, this is your little theta right here. So it'd be cosine, yes. So Fx is Fx. Let me go and put it on the side. Fx is simply F cosine of theta. Okay, and what you said earlier about the friction, yes, it is mu times mg cosine theta, and Fgx is mg sine theta. It's equal to m times a. So therefore, a is simply this whole gigantic thing over m. Okay. Now this is as conceptual as it could be. There's no number, and it's okay. We just say, well, thanks. There are no numbers to compute. Save my work from punching the calculator. Okay, so this is not something scary, but you should look at the net force here, and since we're only focusing on the x direction, so that you would only look at these three forces right here. They should all add up to m times a, not 0, okay, because it is going up the plane, and it never mentioned about having a constant velocity, so we cannot assume the net force being 0. Okay. Oops.